We're out here in Montrose, California, over at Scott's Performance, where it all started, and we're with the man himself, Scott, and he's here to show us how to properly adjust your stabilizer for all the riders that have them out there, whether that be for the drag strip, everyday commuting, road racing, just whatever the purpose you got, stunting. It really does it all, so he's here to show us how to do it.
Well, first of all, thanks for coming, Sean. And
thanks for having us.
what we're going to do is we're going to go through all of the valving circuits that the Scott stabilizer has and show you how to adjust them and show you how each one does, and even show you a little bit of the innards of what's going on inside there when you're actually using it.
Great.
Okay, well, we're going to start with the basics, Sean, and the first thing that most people are accustomed to is the base valve, the one with the pointer on it. And the base valve is measuring flow of oil from one chamber to the other, and as you turn it clockwise, it's going to stiffen up the resistance from chamber to chamber. So when you go all the way to where it stops, at this point, if we were to turn the bars, you would feel severe drag, meaning it's going to really slow it down. Some guys will even ask, well, how could you even possibly use that at that tension? Well, these units are quite commonly found on salt, the Bonneville salt flats. In fact, we own, I think, 3 or 4 of the speed records on the ZX14s. And Livingston Faulkner this year again set another record, and Paul Thied did also on a CBR 600. He went over 200 miles an hour. So when they're on this setting, those guys aren't going to be doing any turning. So it's important that we give the consumer the full range of what he wants to do, because sometimes you're going to ride the motorcycle to the market, and the next weekend you may be racing it. So again, at full clockwise, when this knob stops is when it's at full stiff. And then you get very definite clicks as you turn it, as it comes out. Usually they have about 24 clicks. You can turn it all the way out and it'll reach a full stopping point, which is there. And at that point, the stabilizer is basically off, meaning some guys don't want to have a heavy feeling on their bike. They don't want to feel anything on the stabilizer until they really need it. That's the beauty of ours, because underneath here is another complete separate system valving circuit. So if you don't like the feeling of a steering stabilizer in your bike, you can turn this part off, and you can start dialing this in to react to whatever high speed impact you might encounter. Now these two do interact with each other, because this controls oil flow from one chamber to the other, and the more you slow the oil flow down, the less this system is going to react, because the high speed valve is reacting according to velocity of the oil moving back and forth. So if we back this one all the way off like it is now, this valve is going to become much more sensitive because it's allowing the oil to flow more freely. Now I have a screwdriver to show you how this works, and I also have a penny, because sometimes when you're out riding you may want to adjust this and you don't have your screwdriver. You want to do this, so a penny or a dime that fits into this little slot here and turns it. This notch that we put there is just as a reference point so you know where you're at. So we typically send these out at 1.5. So we're going to back this out. Okay, it's stopping there. So now I'm looking at it like, we'll say this is at about the 5 o'clock position. So we're going to turn it in. There's one full turn. That's 1.5. Okay, so that would be 1.5 in from all the way out. Full soft. Okay, if you were going to adjust this valve with the base valve all the way off, we usually recommend you thread it all the way until it stops. Okay, and that's the stopping point. So right now we're roughly 6 o'clock, 7 o'clock. We're going to turn this out 1.5. And at that point is where we typically ship them, because that's where the average user or somebody that's not fully well aware of how this works is going to be most comfortable with it. And again, a penny or a dime fits right in the slot, and you can turn it real easily. The stiffer the base valve is, the less sensitive the high speed valve is. The softer this is, the more sensitive this is. The third control is on the sides. These are the sweep control valves. And the sweep controls are designed so that the slot that's cut in them that the screwdriver fits into is the shaft of an arrow, and then we've machined an angle on the pointer side that creates the arrow head, so you know what it's aiming at. 12 o'clock being straight up, 6 o'clock being straight down. If you're going to use 9 or 3 o'clock, you're going to walk around to each side of the bike. So 9 o'clock on this side would be aiming toward the back of the bike. You walk around to the other side and look at it like the face of a clock, and 9 o'clock would be aiming toward the front of the bike. So you always want to look at it like the face of a clock. And what they do, the vane internally inside here is aiming straight ahead. And it is stationary. It's always going to be aimed straight ahead, and the body is going to move back and forth. By turning the sweep controls, you have 4 different positions that this vane can move. It'll start, the body is moving, but I'm going to turn it like it's a vane. It'll move 17 degrees off center, one way or the other, and then release. So for instance, if you're in a parking lot or you're coming down into a race turn that's a very slow speed, let's say it's a 180 degree turn, and you don't want to be having the resistance of the stabilizer to make that turn, the stabilizer will release as the turning radius gets tighter and give you free movement to go around or negotiate those turns, especially for guys, let's say you're in a parking lot, you know, sometimes you pull up and you got to back into that space and you're twisting the bars. Well, you don't want to be fighting the damper. So again, you have the ability to adjust this to suit whatever individual needs you like. Okay, so now what we're going to do is we're going to give you a little insight by using a clearer top on one of our stabilizers to show you what's actually happening inside. And I have oil in here that's aerated on purpose with air bubbles, and if you look carefully you can see the air bubbles passing through this passage right here, which is the passage that connects the high-speed valve to the base valve. So as I'm moving the vane this way, the oil is exchanging through that valve over to the other side. It's passing through the high-speed valve, which in here is measuring velocity of the oil, and then goes through the base valve, which has a needle, a tapered needle in it, which is changeable, by the way. You can adjust that taper on that needle if for some reason you would prefer something different than what's in them. Some guys like a steeper taper so that each click makes a bigger difference, and some guys like less taper so that as you turn it in, it has less of an effect. When we turn the sweep control, you'll notice there's a hole right there. So here's your sweep control, and as I turn this, you'll see that hole comes up in a different position. So now what you have is, this is controlling where the damper, how far it sweeps out and then releases. As we keep turning it, there's a different set of holes for each position.